Starting section 4.3, continuing on the trend of trying to figure out how to prove that two triangles are congruent, which up to this point, to prove the triangle is congruent, we've had to look at proving every angle and every side that corresponds with every angle and every side of the other triangle congruent to each other to prove them congruent. So now we're going to introduce some postulates and theorems that will make that process a little bit easier for us. Right? So starting off here, we have postulate 19, the side, congruence postulate. Most times you'll just see it abbreviated as SSS. Right? So if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. Right? So this postulate just tells us that all we have to do is prove that all three sides are congruent to each other, and then the triangles will be congruent. Which is basically because if you have three sides that are all the same length as three sides of another triangle, then those three sides can only go together in one way with one set of angles to be, so they'll be the same triangle when you put them together. All right, so we want to prove that triangle KLM is congruent to triangle NMP. This is actually one of the easiest proofs we'll ever do. So we notice there's not a given statement, so we're taking our given from the picture. Which from the picture we can see that side KL is marked congruent to NM. LM is marked congruent to MP, and KM is marked congruent to NP, so that's our given. Right? KL is congruent to NM, LM is congruent to MP, and KM is congruent to NP. Just coming from the picture because they didn't give us a written statement. And so from there, we notice that all three sides are marked congruent. So that would lead us to side as our reason to say that the two triangles are congruent. So triangle KLM is congruent to triangle NMP by SSS. And that's all you have to write is SSS. Everybody in the geometry world knows that that means side congruence postulate. Right. Like I said, that's about as easy as it gets. The given, and then it's proven. Right. Anybody still copying? Move forward. All right. So then we got postulate 20, known as the side angle side congruence postulate, or SAS. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So it's two sides and the included angle, or in other words, the angle is in between the two sides that are congruent. So the two sides are going to be adjacent sides, and the angle that those two sides make has to be congruent. Or if you just follow it around, you've got a side here, then an angle, and then a side. So side, angle, side. All right, so we want to prove that triangle BWZ is congruent to triangle YWX. And so once again, they didn't give us a given statement, so we take that straight from the picture. And from the picture, we can see that segment VW is congruent to segment YW, and segment ZW is congruent to segment XW. So there's our given. And then we try to look to see if there is anything else that could be congruent to each other. When we look at these two triangles, which if we notice the middle where point W is, those are two intersecting lines. And when we look straight across from each other, or the opposite angles at the intersection, those would be vertical angles. And hopefully at this point we know that vertical angles should be congruent to each other. So we can say that angle VWZ is congruent to angle XWY. And we have to use three letters here because we can't just say angle W, because there's multiple angles right there at point W. So, and we're saying that those are congruent because they're vertical angles. So that comes from the vertical angles theorem. And now if we look at what we got this side congruent to this side congruent to this side, and in between those two sides we have this angle congruent to this angle. So if we just look around, we got a side, an angle, and a side congruent to a side, an angle, and a side. So that's enough for us to say that triangle VWZ is congruent to triangle YWZ, and that's based on the side, angle, side congruence postulate. All right. Questions on that one, anybody? And then moving on. Next one asks, is there enough information given to prove that triangle LMP is congruent to triangle NPM? All right, so if we look at those two triangles, right, just from the markings on the triangles, we know that LM is going to be congruent to NP, and segment LP is going to be congruent to segment NM. It's given. And then if we look at the two triangles, anybody see anything that would be congruent? Something that's not already marked? Right, this inside side right here. So we look, both triangles are using this side, right? MP. And so we know that MP is going to have to be congruent to itself, right? MP is congruent to MP, which that MP represents a side for both triangles. Anybody remember what property would allow us to say that something is congruent to itself? All right, it is the reflexive property. Reflexive property of congruent segments. So any segment would be congruent to itself, is what the reflexive property of congruent segment says. And anytime we say that something is congruent to itself or equal to itself, that's a reflexive property of some sort, a reflexive property of equality or a reflexive property of congruence. All right. So now, if we look at what we've got all three sides marked congruent. So that would allow us to say that triangle LMP is congruent to triangle NPM. And by what reason, anybody? So all three sides marked congruent. So it's side, 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 SSS. And so is enough information given to prove that the triangles are congruent? Ultimately, the answer is yes. Yes, there is. All right, so the next one says given that side AB is congruent to side PB and segment MB is perpendicular to segment AP, prove that triangle MBA is congruent to triangle MBP. So first off, we're going to list the given. Segment AB is congruent to segment PB. Segment MB is perpendicular to segment AP. It's all given. So we got on our picture, we can mark AB and PB congruent. And then, since it tells us that MB and AP are perpendicular, what's that tell us about angles MBA and angle MBP? If those two lines are perpendicular, what do we know about this angle here and this angle here? If this line is perpendicular to this line. They're both 90 degrees, or we call those right angles. Right? So angle MBA and angle MBP are right angles. And we know that because they told us that the lines are perpendicular, and the definition of perpendicular lines tells us that two lines intersect to form a right angle. Right, so, and now since these two angles are right angles, what do we know about all right angles? All right angles are congruent to each other, right? So, which should make sense because all right angles are 90 degrees. So, they all have the same measure. They should be congruent to each other. So we can say angle MBA is congruent to angle MBP. And that's because all right angles are congruent, or that statement comes based on the right angle congruence theorem. So you can either write it as the right angle congruence theorem or just write what the right angle congruence theorem says, which is all right angles are congruent. All right, so now we've got one set of sides and one angle that are congruent. Anybody see anything else that would be congruent? We don't have anything that would show that AM and PM would be congruent. But what's the easy one to see that's congruent? MB right here, right? Because once again, it's a shared side between the two triangles. So it's got to be congruent to itself. So segment MB is congruent to segment MB. And what property did we say we used to say that something's congruent to itself? The reflexive property. Reflexive property of congruent segments. So now if we look at what we've got a side, an angle, and a side of this triangle congruent to a side, an angle, and a side. And the angle is included in between the two sides. So that would be enough to tell us that triangle MBA is congruent to triangle MBP by side, angle, side, SAS. And then anybody still copying before I switch over? Right. All right. So this last one says use side, side, side to show that triangle NPM is congruent to triangle DFE. All right, so if we're using side, 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 that means we need to be able to show that all three corresponding sides are congruent to each other. So we're going to start off. If we look at PM, it's 1, 2, 3, 4, 5 units tall, right? Which EF, which we can see that it fills the same length there on the grid. That one's also 5. And then we look at the bottom. We got N to M is 1, 2, 3, 4 units. And D to E is 1, 2, 3, 4 units. So since those lengths are the same, that's enough for us to say that segment NM is congruent to segment DE, and segment PM is congruent to segment FE. So that gives us two sides that are congruent. So by side, 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 we need to prove the third side. Which the third sides are not horizontal or vertical, they're slanted, right at an angle. So we have to use the distance formula. If you remember the distance formula, that's x2 minus x1 squared plus y2 minus y1 squared. And then we take the square root of that answer when we get it. So for Pn, we're using the points -1, 6 and -5, 1. So the length of Pn, or the distance between those 2 points, is going to be x2, which is -5, minus x1, which is -1 squared, plus y2, which is 1, minus y1, which is 6 squared. It's -5 minus -1, that's double negative, so we're going to be adding 1 to -5, which is going to be -4 squared. And 1 minus 6, we -5 squared. So -4 squared is 16, -5 squared will be 25, and 16 plus 25 will give us the square root of 41 for P to N. And then we need to do the exact same thing for segment FD. Make sure that it's the same length. So using points 2, 6 and 6, 1. So the length of FD, or the distance between those 2 points, is going to be 6 minus 2 for the x's squared, plus y2, which is 1, minus y1, which is 6 squared. So 6 minus 2 squared, it's going to be 4 squared. 1 minus 6 is -5 squared. And 4 squared is 16. -5 squared, once again, is 25. And so we got the square root of 16 plus 25, which is also square root of 41. So since Kn and Fd are both the same length, now we can say that segment Pn is congruent to segment FD, which gives us 1, 2, 3 sides that are congruent. So triangle NPM is going to be congruent to triangle PFE by side, side, side. And that finishes section 4.3.